Thanks very much. I'm now assuming that I have this microphone working, so I don't have to stay too close to this one. So yes, I'm going to give you a bit of history, try to cram a lot into about 30 minutes to give you really what the contributions that Riccardo has made, and which in many ways influences why we're all here. So the very first rocket flight was one that he did. They had apparently proposed, because they knew there were X-rays from the sun, to perhaps see X-rays reflected from the moon. I don't think they really thought this had high expectations of succeeding to do that. But the results of their rocket flight are here in this slide. This was actually the third rocket flight. The other two attempts actually just failed on launch. But here you can see, if I can get a pointer to it. Maybe it doesn't work. It points somewhere else. Oh, I've got a point here. I forgot. You told me that. Yes. Sorry. And eventually it will show up. Wiggle it around. I've got the top button. Anyway, the plots you see are the results they got of the flight. 300 seconds, 5 minutes. They detected a very bright source, 5 photons per second, which was of course SOLAX 1. And they got a position for that, which is what's in the bottom plot, and the optical position is shown on the right side, and even a star identified there. Okay. All right, give me a hint. Okay, so shortly after that, there was a proposal written by Riccardo to lay out what the future should be. There was a series of future missions. You can see some that you know down there. There was a scanning satellite that was going to be launched. And then at the bottom, you see a 30-foot telesatellite. That was actually, would have been Chandra. But things got changed a bit in both terms of time scale, and Einstein came in between, and I'll get to all of those as well. Okay, so the first real X-ray satellite was Uhuru. It was launched on December 12th, 1970. That's Kenyan Independence Day, from an Italian launch platform off the coast of Kenya. It was launched from there because they wanted it to be in a low equatorial orbit to avoid the poles, basically, where they thought the backgrounds would be higher. Because it was launched on Independence Day, they named it Uhuru, because that means freedom in Swahili. This was not built by a NASA center. Instead, it was built by a group of scientists at American Science and Engineering. And I've listed the names there of some of the more people who were involved at that time. Uhuru scanned the sky, and I've shown in the top a plot. That's a scan of the galactic plane. This is the daily summed average of the scans, and you can see when it's going through the galactic center region, some very bright sources there. These resulted in lines of position, we called them, and you lined those up and figured out where sources were. So that was a map of the sky. About 20% of the data that was taken each day came in as quick look, and that came in almost real time, so that people could adjust where Uhuru was going to be looking, where it was going to scan. So I had a wonderful undergraduate advisor named Giovanni Fazio, who many of you probably know, and I'd heard a little bit about X-ray astronomy. I decided I wanted to do a senior thesis on that. So he called up probably his friend Riccardo at AS&E and asked if that was possible. So I'd go there, and I'd usually go there kind of late in the afternoon because I had classes and labs during the day. And they had a room not quite as big as this section here, and that was called the data room, and it was on the 6th floor. And that was where you could get these plots and look through them, and people would label them. As you might see some labels on this summed one that I put up here. And I would try to identify sources and figure out which were varying and what might be interesting. And sometimes, occasionally, at the end of the afternoon, after most people had gone home, I've only been there maybe an hour or two, but around 5 o'clock, 6 o'clock, Riccardo Giacconi, who had an office on the 8th floor, because he was an executive vice president at ASNE, he would come down to kind of see what was happening. And at least once or twice, brought the guy on the end with him, Bruno Rossi, okay? And, he'd look, I'm the only one in this room. And, I can imagine, he didn't know who I was at all. I'm an undergraduate. And I can imagine he would have said, in Italian, I'm sure, to Professor Rossi, oh, I guess there's no one around, let's go back upstairs. Instead, they'd come over and they'd ask me what I was doing. And that was just amazing. I'd show him these plots, and I'd show him I could label them and what they were. And in the end, I did end up finding an X-ray binary or two. But I took this quote from him, and I took it for a reason. And let me just read it to you. It says, during my university years in Milan, not one of my senior colleagues had ever invited me over to his home, except for Beppo Ocellini. Okay? Riccardo wasn't like that at all. And I don't know how many of you knew him, but he had people over in small groups to his house for dinners or sometimes larger groups. He first lived in a suburb of Boston, but then when he moved from, in 1973, the group moved from ASNE to the Harvard-Smithsonian Center for Astrophysics when it was first founded. And especially then, it was like a block and a half away. So he would invite people over and they'd make wonderful dinners. And what I noticed, I think the first time I was there, was that there was this wonderful landscape painting on an easel. And I asked who painted it. And I was told Riccardo was painting it. And there were some other pictures around. So this is the one thing nobody can take a picture of, and it will disappear from my slides later. But his daughter Anna sent me a copy of one of his paintings. And I'm not sure any of you knew that Riccardo was also an artist, but he really did have many sides to him. Okay. So the first major mission was Einstein, which was launched on July 23rd, 1999. And that's its full scale there. You can see people. That's probably, what? 1999, I'll show you. And you can see people down there, so you can get an idea of the size. And the data also was coming back fairly quickly. And here's a picture. And you'll recognize at least some of these people. This was taken on some weekend day when data was just coming in, and we were kind of there all the time. So there's Riccardo and his wife Mirella, and Leon on the other side, and Graziella Branduardi. Raymond, she's the one holding up this card, and it's a card, but it's actually a Polaroid of a picture of the Einstein observation taken from basically a screen that we could use to look at things. But we got some really nice observations, and you can see there are a couple of them. That's M87, Casse, and who's the bottom one? And Sene, yes. Okay. So although although Einstein was actually a PI mission, Riccardo started with this mission with a guest observer program, with Fred Seward as the lead. And I talked with Fred about this. Apparently, there weren't very many rules for these proposals. They were submitted quarterly, 4 times a year. They were 2 pages in length. He said he even got one that was a handwritten one. And they'd get comments back, and a fairly high fraction of these were actually successful. Okay, the next major mission that Riccardo was involved with was, of course, Chandra, which was launched now on July 23rd, 1999. So it's just celebrated. It's its 20th, or will be celebrating this summer, its 20th anniversary. It really was a huge increase from what Einstein was, just in terms of both sensitivity and angular resolution. And this shows you that the top row are three of my favorite objects from Einstein, and the bottom row is what three of these look like from Chandra. And you can just see the difference, especially with, well, all of them, M87, but especially, you know, Sen-A, Cas-A, it's just been amazing. So what Riccardo wanted to do, he's an interdisciplinary scientist, he had time of his own. What he decided he wanted to do was to use his 500,000 seconds plus an additional 500,000 seconds of DDT time to observe what became called the Chandra Deep Field South. And you can look at this observation, and when you see it, it's pretty obvious probably that there aren't a lot of bright sources in the middle, right? They're all around the edges. So when Riccardo saw this, he got worried apparently. Anyway, he called, and he wanted to know if this was taken with ACES. Is ACES broken? It's blank in the middle. And we were all talking with him and said, no, we have lots of other observations. ACES is doing just fine. This has become a very well-observed field. Neil Brandt now has 7 million seconds on this. This is the highest concentration of supermassive black holes ever seen. Apparently on something the size of the moon, there'd be 5,000 of them. And you can see there's still not an abundance of sources in the core of this. All the brighter ones are toward the outside. Okay. So in 1981, Riccardo left the CFA and became the first director at STSTI. He really basically created that institution from scratch. But he used exactly what he had learned in dealing with X-ray astronomy satellites. He took Ethan Schreier with him, and they assembled a core staff with expertise in all the important areas, in engineering and scientific, in planning and scheduling, and in satellite commanding and operations, because they would be doing it all from Space Telescope. And he just also defined a process to really guide the development of the scientific program. Okay. He made a data archive. He reserved time for large and key programs, a data analysis software, and for the first time, a grants program to support people who got Hubble time. And then also the Hubble Fellows program, which then added to it other fellows, like they were Chandra Fellows. Now they're all going to go back to being called Hubble Fellows in the future to support young astronomers. So he wrote in his book that managing the amount of data that came from HST was akin to drinking from a fire hydrant. And the amount of work was absolutely daunting. Things had to be highly automated in terms of receiving the data, calibrating it, reducing it, and getting it out to people. So he really worked hard to get that system automated. But it was very fortunate that he had done so much work in getting people in all the right spots, because as you all know, there was discovered after launch a major problem with Hubble. It had a spherical aberration of its optics was found, and the primary mirror had been built to the wrong shape. So he assembled a group of people and put them in working groups to solve the problem, and then also to make the best use of the current observations, because it was actually going to be about 3 years until a servicing mission could get there and put basically 2 new mirrors in for each of the detectors to correct the aberration problem. Here's a picture of just the servicing mission, and one of the people sitting there, the one who I would point to if I could, the one with the mustache, got him? That's Jeff Hoffman. He'd been a graduate student when I was an undergraduate, and he was one of the people who led that. This was a great success, and I picked this picture to show because I think it was one of Riccardo's favorites. And this is what he wrote about it. I think Hubble was a very special mission in that it could take pictures with a precision we've never seen before. There is one picture, the Eagle Nebula, in which you can see pillars of gas out of which stars are being formed, and you have the impression of almost an organic process. So science and running Hubble was really key. They were also concerned about basically the status of women in astronomy, and they had the very first Women in Astronomy meeting in 1992 at STSTI. And from that, you can see people here. In the first row, on the left side, there's Nebula Call wearing bright yellow. And if you look up just a little bit behind, almost directly behind her, you'll see Riccardo standing in this group. And then I think it's Margaret Burbidge, probably next to him, and on the other side of Margaret Burbidge is Ethan Schreier. So there was a real commitment from the Space Telescope Institute management to this as well. They wrote something called the Baltimore Charter, and this was really to address the needs to develop a much more diverse culture in which both men and women can work effectively and have satisfactory and rewarding careers. This outlined really serious goals for achieving diversity and criteria for hiring, promotions, and awards, to end sexual harassment, and to use things like gender-neutral language, and basically also concerns for physical safety. Well, Riccardo had several stages of his career. Next, he went to ESO, where he was Director General, and that was from 1992 to 1999. He worked at that time on the 8.2 meter VLT telescopes at Panama Observatory in Chile. I think these are at 16,000 feet. And the first one of those was completed before he left there. And then he moved on to AUI, where he became president from 1999 to 2004. And AUI, you may not be as familiar with as the other institutions, but it manages NRAO and Green Bank Observatory. And as part of this, the US joined and built part of ALMA. And here's a beautiful picture of ALMA under the southern sky and the Milky Way there. Okay. Well, for all of his work, Riccardo received quite a number of prizes, and these included the Wolf Prize in Physics in 1987 for his research in X-ray astrophysics, the National Medal of Science in 2003, and the Nobel Prize, the top prize of all, in 2004. And I have some sort of family pictures to show from the last couple of those. This is actually all on stage there. All 8 of the winners of the National Medal of Science 2003. Riccardo is the third one from the left. He's the one with glasses looking at the person who's taking the picture. Okay. Here's another couple from the National Medal of Science. This is Riccardo and his wife, Camilla. And on the other side, that's Ethan Schreier and Riccardo standing in front. They put posters up for each of the medal winners. Harvey and a few others were also there. The Nobel Prize was, as I said before, the top sort of prize that one can win in physics. And it's for pioneering contributions to astrophysics, which have led to the discovery of cosmic X-ray sources. And this one just shows the diploma that Riccardo received for that. So here are some of his colleagues who were there: Ethan Schreier, Herb Gursky, Riccardo next, and then Harvey Tannenbaum, all dressed up in their tuxedos. So there are a prize lecture that goes with this, and there's one picture there from the prize lecture, and the picture that is behind, you can see is a source that seems to be varying. That's from Uhuru. So Uhuru, it scanned the sky, but it could be slowed down. So it could scan across, it could spin much slower and scan across things longer. So that's the X-ray pulsar, SENX3, basically as it goes through the whole window. It's not getting brighter in time. That's just how much of it is getting into the detector. But you do see the very regular pulsations that happen there. There were a lot of other meetings that happened, more family pictures. This one is actually from the Bologna meeting in 2009, but they were always good to have, conversations, discussions, lots of laughing. Riccardo came back for the Chandra 10-year celebration, and he had at that time still was continuing to think about and look at X-ray observations. So this was after he'd retired from AUI, but he had then published a paper in 2009, which was the VLA survey of the Chandra Deep Field South 3, X-ray spectral properties of radio sources. So he still, remained his love of the X-ray studies. So I blew up the bottom of this poster, and you can see it's signed at the bottom by both Riccardo and Harvey Tannenbaum. The top has a lot of other people, the astronauts from the mission. Marty Weisskopf is there, and several others. But the signatures at the bottom are what you should notice. I just wanted to end this talk with a last picture of Riccardo and his deep survey observation, and a quote from his book, which says, "After many years of helping others to do their science, it was great to be able to stare at my own data and let them flow through my fingers as if panning for gold." Anyway, thank you guys very much, and it's nice to be here and to talk with you about Riccardo.